We are Abby Atkins, Ariana Siegel, and Delia Trejo, and we're talking about stochastic matrices in board games. A stochastic matrix is a probability matrix which can help determine possible outcomes of a situation. Usually it's a square matrix with elements between the numbers of 0 and 1. The transition matrix is also called a Markov matrix or Markov chain to help determine the transition between two possibilities.
So one application for the real world for Markov chains that we found is that it can be used in board games. So a lot of schools, we read some articles, a lot of schools are actually using the board games to teach their students Markov chains and things like that. And what they find in the board games is that you can use it to determine the likeliness of a player landing on a certain square or the probability of how many moves it will take you to get to the end or different things like that. So basically, when you look at the boards, it's just a giant square that's broken into other squares. Taking that idea just for a basic square with 4 different corners, you can see the matrix example we have here, and you can put that into a transition matrix to figure out the probability of which part of the square you would land on. And so we use that same idea for things like Monopoly, which is the same thing, just on a much larger scale because the Monopoly board is a lot bigger. So for Monopoly, here on the screen you can see an example of a matrix that we have here. You can kind of see the example of the board because the squares are around in a Monopoly board, and you can see that there's a lot of zeros because in this example each square is going to be different. One advantage that we have researched that people have found in being able to predict these things is that they can figure out where their opponent will land and the likeliness of their opponent landing on something that they can buy, and things like that.
You could also use these matrices in choosing ladders. In choosing ladders, it's another game where you can easily depict the use of Markov's change. This is one that's very, very simple that could be used on a 10 by 10 or a 2 by 4 board. You can ask the question, what is the probability that will land on the next square? And as you can see from the picture, you could generally see that the probability of landing on space 3 from space 1 is a 25% chance. You could continue using this to see how many times you could land on each space.
So here's our sources, and you can see that the matrices can have many different applications within different board games, and depending on the board game will kind of depend on the size and the way that you're going to manipulate the matrix, but it's very useful for things like this. Thank you for watching.